Our robot is named Steve, Super Technical Electric Vehicle Experiment. We went with a box design that is sturdy, but we made it lightweight with plates. We have 4 drop-on attachments and 1 wall runner for alignment. And in total, our robot has 4 motors and 4 sensors.
For strategy, we created a ranking system 1 through 10 on 3 factors: location, difficulty, and time. For the past 5 years, we've all built and coded. This year, we primarily divide into our specialties. We tracked our progress on different missions with our Scrum board. We tackled missions based on rank and proximity to each other, starting with bench.
We started with bench because it was the closest and offered a lot of points quickly. In just 9 seconds, we earned 100 points, including our innovation project piece and 3 health units. Since we had a tough time getting the right angle with the pivot, we iterated the fixture design to match the bench.
For run 2, we started with a gravity-powered arm that lodges into step counter. We did this because it makes the whole thing faster. We also have a wall runner with a backup pivot action to get us precisely where we need to be. Next, we go to treadmill. For that, we have a series of gears driving a tire that moves the pointer quickly. That took a lot of time to figure out so the gears wouldn't pop. Next, we go to row machine. Our mechanism involved a lot for that. At first, we used an adjustable pinching mechanism, but we iterated and developed this one for consistency.
The first part of this run uses an arm for boccia share. Our design changed a lot with the basketball mission because we wanted to use a linear actuator to lift it. We had to abandon it because we couldn't lift it high enough, and eventually redesigned it to an arm. A few days ago, we decided to knock the man off the slide on our way back to base. Sorry if we gave you a concussion.
For pull-up bar, going under the bar is a very tight fit. We had the line follow and move very slowly. For boccia, we dump a lot of blocks quickly. We're lucky if we get the yellow one in the target. For our final mission, we use a plate and a Lego string attached to 2 gear-down motors to pull us up. We knew the lift was a harder challenge, but we set the goal in the beginning to achieve it.
For programming strategy, we used a similar approach for each of our runs. We used light sensors for line detection to help the robot pivot and line itself up for line following. Here's our code for the second run. This part of the code turns the robot until it senses the black line, then moves the robot forward and then pivots again to find the line to set us up for line following. This next piece is line following code. The code takes a value from the color sensor and using some simple math creates either a positive or negative move steer value for the drive motors to keep the robot on the edge of the line. To save time in transition between runs, we put each run in a my block and link each my block together in one continuous master program. The robot pauses between subprograms, waiting for a push of a button to continue the next run. Because we linked all our programs together in one master program using my blocks, we wanted to be able to cancel master program in the middle of a match and with brick buttons quickly rerun any subprogram. We designed the program to do that.